Graphically representing data is essential for interpretation and conveyance of information. We all know that it's easier to express ourselves or express a point using pictures. And different graphs will have different advantages or disadvantages based on the data available as well as the audience that you're trying to reach. So there are a number of different types of graphs that we could use, and this is only a small subset. We can have histograms, stem and leaf plots, box plots, scatter plots, and line charts. Now, a histogram is simply a column type of chart of a frequency table. So we calculate the number of occurrences within a particular bin. So in this case, on this slide, we have the bins of 0 through 50, 51 through 60, 61 through 70, and so forth. We calculate the frequency of the occurrences, and then we plot them using this type of bar chart. And this is what's known as a histogram. And you can actually see the shape of a curve actually being developed, where towards the left it seems to be a little bit down as a tail. It peaks up into the middle and then tails off again. And not specifically in this case, but in other cases where that second bar might be a little bit higher, you might actually even say that's a bell curve, and we might actually be able to see a normal distribution. Now, when choosing the number of bins, generally 5 to 10 bins should suffice to see the shape of a data set. And you may have to adjust this accordingly because of certain variances or outliers that may occur. Now here's an example of a stem and leaf plot. And while you can do this in Excel, it's not as easy to do in Excel. So what we have here is an example from another statistical package. And below, we actually see the corresponding histogram. And in reality, a stem and leaf plot is very similar to a histogram because it kind of shows you the distribution of the data as well. The actual stem refers to the first number or some significant digits on the left side of the number. So in the first row you see it's 43, so we have the 4 and then a 3. And then it decides to create a secondary bin with all the 4s that have 45, 46, 47, 48, and 49. And so each one of the leaves, which are the numbers to the right of that little bar, indicate the number of entries that are at a 45, a 46, or 47, and so forth. And if you go down to the corresponding histogram, you can see that they kind of match as well. Now, a box plot is really good at depicting differences between the groups. And what we have are different variables or different groups or different experiment numbers, 1, 2, 3, 4, 5, and we're testing some y value here. The actual y value isn't as important right now, but this is just for demonstration purposes. Each one of the groups has a separate, what's called a box and whisker plot. The center part of the box represents the interquartile range. This interquartile range is the second and third quartile. That middle line actually represents the median value for, in this case, let's say group 1. And then the two little dashed lines are the first quartile on the bottom and the fourth quartile on the top. In this case, so this shows you how the distribution is for group 1 or experiment 1 in this case, and how they differ among other groups. And so you can clearly see the difference in this example, that group 1 has a higher median than group 2. It also has a wider variance. Some box plots will also have these little circles or stars, as you can see in the bottom of group 1 and in the bottom and top of group 3. Those actually represent outliers. And those are numbers that kind of fall a little beyond what should the quartile ranges be. Now, a scatter plot is very simply the actual data points on an XY axis, and this is known as Cartesian coordinates. They're very good to visualize trends. In this case here, we have the eruption duration and the waiting time between eruptions for Old Faithful. And it's clear to see, as these are plotted on the graph, that the longer the eruption duration, the longer we would have waited between eruptions. So an analyst might look at this and say, there's some correlation or there's some connection between if there are longer waiting times that the eruption is actually going to be longer in duration. We can also use this to put trend lines to kind of see what this graphical trend is. So we know in this case that it's sloping upward, and we might have another one in which case it's sloping downward. Finally, we have line charts, and line charts are very good representations of displaying time period data. So we might have a certain number of periods here, 25 periods, they could be months, they could be quarters, and we're looking at the stock price, and we can clearly see trends and valleys, and you can see seasonal effects among some other things. But these charts definitely show relationships between prior periods and current periods.